Welcome to yet another lecture on how to factorize in algebra. Today we're going to look at recognizing perfect square trinomials, and we're going to learn what we have to look for. If you are not already subscribed to my channel, feel free to press subscribe below and to join us daily. I have lectures on my channel from grade 1 all the way to senior school, and you can always go catch up there as well. Right, so we want to learn to recognize a perfect square trinomial. How do we do that? Well, a perfect square trinomial is the answer to a binomial which has been squared, like this one below. That's a binomial. It has two terms and it's been squared. You can see there. If we were to write this out, it would be a minus 2 times a minus 2, a binomial squared. But it has to be, if it's going to be a perfect square trinomial, it has to satisfy the following points. So let's have a look at them. So let's use this as an example. There's a trinomial. Basically, the first and the last terms have to be positive perfect squares. There they are. They are positive perfect squares. Do you see them? You see we have a positive x squared. That's a perfect square. And we have a positive 4. So that's the first thing you have to look out for. So that's step number 1. Now, step number 2, the middle term, which is this one here, okay, is equal to twice the product of the square root of the first and the last terms. I know that sounds like a mouthful, but it's not so bad. So the square root of that would be x, and the square root of that would be 2, and twice the product of these two. So these two actually come together as 2x, okay? Twice the product of that, 2 times 2x is 4x. So you can see that is actually a perfect square trinomial then. Okay, so that is how we're going to work them out. We'll use these on the next two screens, these 2 points, to satisfy them and see if they're perfect square trinomial. So let's look at the next one. Is this a perfect square trinomial? So let's look at point 1. It says both the first and the last terms are positive perfect squares. This is a positive perfect square, and that's a positive perfect square. Okay, so those two satisfy it. Then it says the square root, let's look at it. The middle term is equal to twice the product of the square root of the first and last. Okay, so we've got to take the square root of that, the square root of that, and multiply by 2 and see if it comes to that. Okay, well, let's have a look. Square root of x squared is x. Square root of 4 is 2. And the product of them is 2x, and it's twice the product, so that would be 4x. And this is 5x. So guess what? This does not satisfy our requirements, so it is not a perfect square trinomial. Let's look at the next one. We're going to see that that's a positive perfect square, and that's a positive perfect square, so it satisfies that. And then let's see, the square root of a squared is a, and the square root of 16 is 4. And twice that is going to be equal to 8a, which is equal to that. So guess what? It does satisfy. It is a perfect square trinomial. Next one, let's see if this one is. We've got a positive perfect square and another positive perfect square. Right, so that first part is satisfied. Now we take the square root of each, so b squared square rooted is a b, 49 square rooted is 7, and then twice that is going to be equal to 14b, and yes, we have it there. So it satisfies all the requirements, and we can say it is a perfect square trinomial. Okay, one more. Let's look at this one. We have a positive perfect square. We have a negative perfect square. Already we can just stop there and say it's not going to work. It's got to be a positive. Okay, so that one wouldn't have worked very well. So this is actually not. Okay, right. So you've got the idea now how to use these rules here to see if it's a perfect square trinomial. Let's just go look at them again. Both the first and the last term are positive perfect squares. So they've got to be a plus and a plus. And then the middle term, we use what we've just done now, where that is twice the product of the square root of the first and the last terms. And that's another way of factorizing. So we'll look at some more factorizing tomorrow.